we are starting factoring trinomials. I want y'all to realize trinomials means 3 terms. So yesterday we did grouping, which was 4 terms, and GCF, which really is any amount of terms. Okay, but today we're focusing only on trinomials. Okay, so 2 of the things that we learned yesterday, the first 2 questions yesterday, are the same 2 first questions today. Are the terms in order? Is there a GCF? These are always things that you should pay attention to. Now, we were nice, and all of the notes is in order. And I believe all of the practice is in order as well. So we've set these up nicely for you. There are GCFs on some of them, though. Now, if you pay attention to the front, it says factoring trinomials with a leading coefficient of 1. That means the front of them, there's a 1 on all of them. So these will not have GCFs because you can't have a GCF bigger than the smallest number, and the smallest number here is 1. Okay, we are doing what we call the snowflake. Most Algebra 2 teachers taught you this method, but these are the methods. This is the method we're doing. So we're going to kind of talk about a couple things to prepare you for this first, and then we'll jump in. So I want you to realize that quadratic standard formula, which we're factoring quadratics, is ax squared plus bx plus c. A is the number in front of x squared, b is the number in front of x, and c is the number with no letter. Okay? So knowing that, we draw our snowflake. Doesn't have to be beautiful. Half the time mine look crazy. That's okay. Now, I want you to realize that we're going to put A times C here, which means this is going to be a number, not a letter. Okay? We're going to put B on bottom, which means this is going to be a number, not a letter. Okay? And then we put AX here, AX here, which means you're going to have a number with a letter, a number with, dang it, a letter. So the only spots you're going to have a letter are here and here. Now, there are special cases. We are going to do one of those today, and we'll discuss it when we get there. But for the most part, this is what it's going to look like. Now, this is also going to be a number and a number, but you have to find those. They're not given to you. You have to figure out what multiplies to give you this and adds to give you this. Does anybody remember this? Does it look familiar at least a little bit? You've been doing this in some way, shape, or form since your freshman year. Okay? So it should look...
Can you go back? You froze again.
I froze.
Yeah.
Okay. Where did I freeze?
You put like the number on the X.
Okay.
You said, oh
so
shoot, and you froze.
8 times x, 8 times x. Okay, that's the only spot you'll have a number. So then you're going to have a number here and here, but these numbers you have to find. They're not given to you in the quadratic formula. So you're looking for what multiplies to give you the top number, but adds to give you the bottom number. So we're going to go over some examples, and then it'll make a lot more sense. I want you to realize that A, B, and C are numbers 90% of the time. 90% of the time. Okay? So let's look at number 1. Okay, so what does my A equal here? Well, if there's not a number in front of x, what number can we put? 1. Okay, B is the number in front of x, which is -2. And C is the number without a letter, which is -3. Okay, so A times C on top, 1 times -3 is -3. B is -2. Okay, and A is 1 with an X, 1 with an X. So that's all the stuff that we fill in that's given to us. Okay, now we need to figure out what multiplies to give us -3 and adds to give us -2. What multiplies to give us -3, but adds to give us -2? Well, I want you to realize -3 is prime, so the only thing that multiplies to give you 3 is 1 times 3. But it's negative, which means one of these has to be negative and one of them has to be positive. Since it has to add to a -2, I know my bigger number needs to be negative and my smaller number is going to be positive. Now, I'm done because a is 1 and there's no way to simplify, which we'll talk about on the back. My factors are x plus 1, x minus 3. Any questions, comments, concerns? Okay, let's look at number 2. A is 1, B is -5, and C is -6. Now, one thing to know is that it's super important to remember your signs in front of your numbers here because it changes everything if it's negative or positive. Okay, 1 times -6 is -6. B is -5. A is 1. A is 1. Now, what multiplies to give you -6 but adds to give you -5? Well, I know my top number is negative, and the only thing that multiplies to give you negative is a negative and a positive. Okay, 1 times 6 gives me 6, and 2 times 3 gives me 6. So I want you to realize with 1 being negative and 1 being positive, we're going to subtract to find -5. Which one of these is going to subtract to give me -5? One and 6 or 2 and 3? And my 6 is going to be my negative, and my 1 is going to be positive because this is a -5, so my bigger number needs to be negative. There's my answers. Okay. I want y'all to try number 3 while I take attendance. Okay, what does A equal? B is
-6.
And C is
8.
Okay, so A times C is 8. B is -6. Oh, it might help if I'm sharing my screen. Here we go. And then A is 1 with our x, 1x. What multiplies to give me 8, but adds to give me -6?
-4 and -2.
Yes. One way you could have known it was a double negative is because you have a positive on top but a negative on bottom. Okay, so we have x minus 4 and x minus 2. Now, if you ever need to check your work, you can double distribute this. X squared, or x times x is x squared. X times -2 is -2x. -4 times x is -4x. -4 times -2 is +8. So I have the x squared, I have the +8, and -2x minus 4x does equal -6, so therefore this is correct. Okay. Now we're going to skip 4 and 5 just because this gets repetitive, and we're going to look at number 6. And then we're going to go to the back. Okay. So I want you to realize, what is A? What's B?
38.
And C?
4.
Okay, A times C is 4, B is 3, 1x, 1x. What multiplies to give me 4 but adds to give me 3? I want you to realize they're both positive, so both of these numbers need to be positive. Will it ever work? No, because think about it. The factors of 4 are 1 times 4. Well, 1 plus 4 is not 3, and 2 plus 2, or 2 times 2, which is 4. So this will never work. So what we call is prime. So if you read that little box at the very top of the notes, it says, if b squared minus 4 times a times c is a positive perfect square number, then it is factorable. If it is not a positive perfect square number, then it's not factorable. Therefore, we call it prime. What is a perfect square number? Does anybody know? A perfect square number is 1 because 1 times 1 is 1, 4 because 2 times 2 is 4, 9 because 3 times 3 is 9, 16 because 4 times 4. Does that make sense? Those are perfect square numbers. Okay? So if we look down here, we need to test out b squared minus 4 times a times c. So b is 3 squared minus 4 times a is 1 times c is 4. Y'all, this is the only calculator I have, but your calculators do this too. So we're going to type it in. Just like this. I recommend you do use parentheses because if it's negative, it just helps everything work out. And that equals -7, which is not positive and it's not a perfect square, therefore this is prime. It is not factorable. Okay, any questions with this? Okay, so let's flip to the back. Now, if you notice on the back, it says factoring trinomials with leading coefficient. That is not 1. Okay? So if you notice, there's a number in front of x squared on all of these. Or not all of them, but most of them. Okay, so knowing that, we need to find our a, b, and c. Okay, so one thing I want you to realize is that we make sure it's in order. X squared, x, no letter, so it's in order. And there's no GCF of all 3 numbers. Does anything go into 4, 7, and 3? No. Okay, 3 and 7 are prime, so we don't have to worry about it. A is 4. B is 7, and C is 3. So remember, A times C goes on top, so 4 times 3 is 12. B is 7. AX, AX. What multiplies to give me 12 but adds to give me 7?
4 and 3.
Positive 4 and positive 3. Now I want you to realize with these two numbers, order doesn't matter. If you put positive 3 here and positive 4 there, that's totally fine. Okay. Now, this is the different step. We cannot say that these are our factors because 4 times 4 does not give me 4x squared. Okay? But 4 over 3, if this was a fraction, does not simplify, therefore that is a factor. Now, 4 over 4 does simplify. You can divide both numbers by 4, and you get 1x over positive 1. There's my factor. So the only step added is that if one of those simplifies, you need to simplify it. Now a quick check. The first 2 terms should equal the first term, or 4x times x is 4x squared. And the last 2 terms, 3 times 1, should equal the last term, and it does. Now that doesn't always mean it's right, because we didn't look at the b term, but it is like a quick little check to make sure your numbers are right. Mostly right. Okay, so let's look at number 8. A is 4, B is negative 11, and C is 6. There is no GCF, and it is in order. 4 times 6 is what? What's 4 times 6, y'all?
24.
Okay, and then B is negative 11. AX. What multiplies to give me 24 but adds to give me negative 11? Well, when my top is positive and my bottom is negative, I know I'm going to have 2 negatives. Now, if you struggle with finding these numbers, I know y'all don't have a graphing calculator, but, or you might, but you're not supposed to. You won't on your test. You can come here and you can do division. So I always start with like 2. 24 divided by 2 is 12. 2 and 12 do not make 11. 24 divided by 3. 3 and 8, well, that does make 11. So 3 and 8. Now, 4x over 3 does not simplify. But here, 4x over negative 8 does. So what can you divide both of those numbers by? Well, 4 goes into both of them. And this ends up giving me x over negative 2. So then with our quick check, 4x times x is 4x squared. Negative 3 times negative 2 is positive 6. There's your answer. Okay. Look at number 9. Is it in order? It is in order. Okay. I want you to realize there is a GCF though. 3, 9, and 30. Well, 3 can go into all of those. So we have to take that 3 out. But we cannot forget about the 3. So I'm going to go ahead and put the 3 down here in front of parentheses so I don't forget that it is a part of my solution. Okay? But I'm going to divide that 3 out, and I end up getting x squared plus 3x minus 10. And that's what I'm going to use to find my a, b, and c in factor. So a is 1, b is 3, c is negative 10. A times c is negative 10, b is 3, 1x, 1x. What multiplies to give me negative 10 but adds to give me 3?
Can you slow down?
Yes. When y'all tell me those numbers, I'll take it that you're ready for me to keep going.
Positive 5 and negative 2.
Yes. Now, since these are 1, those are my factors. Okay, so let's look at number 10. So first things first, is it in order? I'm sure y'all are all saying yes in your head. Okay, does it have a GCF? I'm going to wait for this answer.
Yeah.
What is the GCF?
4.
4. So I'm going to take that 4 out, but I'm going to put it on bottom in front of parentheses so I remember that it's part of my answer. So I divide everything by 4 and figure out what that equals. I get x squared plus 6x plus 7, and that's what I'm using to factor. The best part about taking out a GCF is usually it makes your, not always, but sometimes it makes your leading coefficient 1, which means there's no simplifying in your snowflake. So A is 1, B is 6, C is 7. A times C is 7, B is 6. 1x, 1x. Now what multiplies to give you 7 but adds to give you 6? Can you think of anything?
It's prime.
It's prime. But freeze, we did take out a factor. So let's double check. B squared minus 4 times A times C. So 6 squared minus 4 times 1 times 7 is 8. 8 is not a perfect square number, therefore it is prime. But we did take a factor out. So what was left over when we took that out? So this was really just a GCF problem. But since it had 3 terms, we had to double check. Okay, these last 2 are special cases. These look ugly, and they are, okay? But these are a little different. Now I want you to realize on this one we have 2 letters, okay? Our main letter, I'm going to say, is Y. So we're technically, y'all, going to put a Y here with our A because we have Y squared, and then we have a Y, and then we have no Y, okay? Kind of like our AX squared plus BX plus C, right? So we're going to treat Z as if they are numbers. Okay, so there is nothing with Y squared, so that's 1. But with my Y in the middle, I have a negative Z. And my C is negative 6Z squared. Is everybody okay with where I got these 3 things? Okay, so knowing this, A times C is negative 6Z squared. B is negative 1Z. Now, my A is 1. What multiplies to give me negative 6? I'm ignoring the letters for right now. What multiplies to give me negative 6 but adds to give me negative 1? What multiplies to give me negative 6 but adds to give me negative 1? We can start writing our factors. 1 times 6, 2 times 3. Those are our only options. And since it's negative, we're kind of subtracting. Well, 1 minus 6 would only give me 5 in some way, shape, or form. But 2 minus 3 does give me negative 1, so 2 minus 3. Now, z squared is z times z. Negative 3z plus 2z is negative 1z. So here are my factors. Any questions with that one? Okay, so when we talk about our standard form, ax squared plus bx plus c, I want you to realize that x squared and x are just placeholders for what we don't know. So it's really just anything squared plus something times anything plus a number, okay? This can represent those variables. It's just something, okay? Something we don't know. We don't know what x plus 1 is. Okay, so knowing that, we can replace it to kind of make this look easier. So I'm going to say y equals x plus 1, and I'm going to plug in y in place of x plus 1. So this gives me y squared plus 6y plus 8. I'm just doing this to make it look pretty. Prettier. Because x plus 1 everywhere does not look pretty. Okay, so my A is 1, my B is 6, and my C is 8. A times C is 8, B for the bottom is 6, A sub y, or not sub y, sorry, AY, AY, because y is my letter I'm factoring, not x. What multiplies to give me 8, but adds to give me 6? Anyone?
4, 2.
Yeah, positive 4, positive 2. So I get y plus 4 and y plus 2. But I'm not done, because now I have to substitute this back in there. I have to plug it back in. Okay, so I get x plus 1 plus 4, x plus 1 plus 2. Well, that just gives me x plus 5 and x plus 3.